Okay, for this section, or I should just say, for this problem, sorry, this is going to be kind of our grand finale for the section here because of the fact that this is going to be us going through and using the heavy side to express a piecewise, taking the Laplace transform of a heavy side function, and then going through and using a differential equation, taking its Laplace transform, and going ahead then and taking the inverse, and then finding the function and graphing it. That is our solution. So it's a very long problem with a lot of steps to it. So the first thing we have to do in this problem is go in and take our forcing term and express that using the heaviside function. So to do that, we've got our f of t, and remember again, it's equal to the definition of the function, which is t, times the interval function on that interval 0 to 2. And then it's just plus 0 for the rest because the function is equal to 0 for t greater than or equal to 2. So the next thing to do is now express this using our heaviside functions instead of interval functions. So that's t times ht minus 0 minus ht minus 2. And then if we distribute, this is t ht minus t h of t minus 2. And we'll notice that we can't go ahead and take the Laplace transform of this because these t's here do not match. We have a t here and a t minus 2. So what we have to do is rewrite that like we did earlier in this section. And write it as t h of t minus parentheses t. And now we're going to go in and subtract 2 and add 2 to that t. And that still times the heavy side at t minus 2. And now we're going to break it apart so that the t minus 2 stays intact and the 2 flies off separately. So we're going to have the t h of t minus t minus 2, heavy side t minus 2, and then minus 2 times the heavy side at t minus 2. And we are now ready to go in and now rewrite our f of t using this definition with our heavy side function. So that'll be the next step in solving this problem.